Good morning, aspirant. In this video, you are going to learn each and everything about hardness and softness of water. You are going to have a holistic understanding about this topic, and that's all. So, if we want to define hardness and softness, it's basically on lather formation. This is lather. In Hindi, it's called jhaak. Okay. So, if any water forms lather, lather on treating with detergents, soap, and all. So that is basically soft water, and that is more usable. So we use generally soft water. So if uh, on the basis of formation of lather we differentiate water, then it will be of two type. One will be soft water. In soft water, it will be let me write in another way. Make sure you are making note with this video so that you can understand and you have a proper document ready with you. Okay. So second, hard water. Lather formation. Lather formation. It is very easy to form lather in soft water. So yes, no. Okay. Now, better to write, it is easy to form lather, because in hard water, very little amount of lather sometimes forms. So it is difficult to form lather. Okay. So you can avoid the extreme statement like it forms and it cannot. So you try to uh, write instead these terms, easy and difficult to form a lather. Okay, so you have understood the basic things about softness and hardness. And what is problematic for us? We use soft water, but there are many water, those are hard. So this hardness of water arises due to some ions, due to some salts in the water. Those salts are softness and hardness. You can see based on the salts present, which elements, if I ask you that which compounds make a water hard, that is basically some salt. We know some salt means some cations and some anion. So there will be some cations and there will be some anions which will make some salts. Those salts, if present in water, that makes the water hard. Those cations are Ca2 plus, that is basically calcium, and Mg2 plus, that is magnesium. And the anions are 8CO3 minus, that is bicarbonate, Cl minus, that is chloride, SO4 double minus, that is sulfate. So these are cation and these are anion. If these are present in a in a water sample, then the water will be hard. Now, what will be the salts? So you combine those: calcium bicarbonate, calcium chloride, calcium sulfate, magnesium bicarbonate, magnesium chloride, magnesium sulfate. So I am just writing few names. Okay. So another I am writing with bicarbonate, another one with this. For example, if I combine calcium with bicarbonate, then it will be called calcium bicarbonate. As calcium is 2 plus, then this will be 2 unit of anion will be required, because the negative there is one negative charge only. So to neutralize two positive charge, we will need two set of this anion, right? So NaHCO3 whole 2. So this will be formula of calcium bicarbonate. Again, if I want to write calcium chloride, then it will be CaCl2, isn't it? CaCl2. If I want to write calcium sulfate, that will be, this is 2 plus, this is 2 minus. So one uh, radical, one anion is uh, enough to balance the charge. So it will be CaSO4. Okay. So these will be those salts. So you will get total 6 salts. Okay. So any of them, or two or three of them, or four of them, or all six of them may be present. If they are present, they will make water hard. Now, can we remove the hardness of water? Yes. On the basis how easy is to remove the hardness, on that basis, hard water is classified further into two parts. One is temporary hardness. Another one is permanent hardness. In temporary hardness, in temporary hardness, it is difficult to remove the hardness. So removal of hardness. What I said difficult. No, no, no. Temporary is, it is easy. It is easy to remove the hardness. Okay. Now it is difficult. So that is permanent. Hardness has become permanent. So it is very difficult to remove the hardness. Okay, for permanent hardness. So removal of hardness easy for temporary hardness. Removal of hardness is difficult for permanent hardness. Now, which salts among them, if they are present, I will be calling it temporary hardness? Now the answer is, if with any cation, any of these two, if bicarbonate is present, then those will form temporary hardness. So those salts which have bicarbonate, that will basically generate temporary hardness in water. So which ions will be, which salts will be there? Bicarbonate means calcium bicarbonate and magnesium bicarbonate, isn't it? So CaHCO3 whole 2 and MgHCO3 whole 2. So if these two salts are present, then the hardness is easier to remove. Why it is easier? How we can remove this? Suppose I have one water sample. In this water sample, I have these two salts, or any one of them. Okay, both can be present or any one can be present. Now, if I just heat it, this is the sign of heat, okay, this triangle. If I heat it, then what will happen? We will get some precipitation. We will get some precipitation. And the remaining portion of water, it will be soft. So hardness will be removed. So how simple it is? Just you heat it. So it is basically easy to remove the hardness. That's why it is called temporary hardness. Okay. Now if something is getting precipitated, now you can filter it. Simple filtration. With filtration you can remove this. So now you can get soft water. Very easy, right? Now what happens in heating? Remember, if bicarbonate salt is there, then it is basically soluble, but carbonate salt is insoluble. What reactions happen here in this system? Suppose CaHCO3 whole 2 is present. Okay, if it is present, then that will generate temporary hardness. Now if we heat it, what will happen? Any bicarbonate salt, remember this, rather write this, what I am saying. Any bicarbonate salt, when it is heated, it generates carbonate salt and CO2 is formed. So carbonate CaCO3 will form calcium carbonate plus CO2 plus water. So I am not making reaction balance here. So this will be basically product, and this calcium carbonate, it is not soluble, so it will get precipitated. So this precipitation is basically of CaCO3 calcium carbonate. Okay, so this is how temporary hardness is removed. Temporary hardness means the presence of calcium magnesium bicarbonate salt. So bicarbonate salt, when it is just heated, bicarbonate is converted to calcium carbonate and the CO2 will be removed. Okay, and this water remains. This will be basically soft water. Okay, so this is very easy, I hope. Now it is difficult to remove permanent hardness. Now, if bicarbonate salt is present, that is basically generating temporary hardness, then other two ions, if these chloride salt and sulfate salt, if these are present, then that will basically generate permanent hardness, right? So here Four salt you can write CaCl2, CaSO4, MgCl2, MgSO4. So you can write these four examples. Now it is very difficult to remove its hardness. So what we will do? Will will chemists give up that no, we can't remove? No, they will try and they will make some way out. So what are the ways by which someone can remove this hardness? One way is they can add sodium carbonate, Na2CO3. So first process by which we can remove permanent hardness is adding Na2CO3. What will happen here? Suppose in this permanent hardness, in this water sample, either of these four salts will be present. For example, I am taking uh, CaCl2. Suppose in this water CaCl2 present. That means the hardness in water is permanent. Now, if I add CaCO3, what will happen? In CaCl2, what ions are present? Ca2 plus and Cl minus. These ions are present. In Na2CO3, which ions are present? Na plus and CO3 double minus. Now what will happen? Just exchange these ions. Okay. So our product will be here, in product will be CaCO3 and NaCl. Now this will be formed in our solution, and as we know here CaCO3 will be precipitated out and NaCl will be in this water. And we can obviously NaCl can be removed by evaporation technique. Okay, if you just heat it, then evaporation or distillation, any technique you can use. Okay, so now you will be filter it out and it is basically removing the hardness. So this carbonate and this calcium, these are getting removed and chloride is getting removed. Okay, so that's why the permanent hardness in this way they are removed. It is up to this point. If you are in school level, then up to this point if you learn, that's absolutely okay. But if you are in any competitive exams, for example NEET, JEE, then this after discussion is very important for you. The another way to remove permanent hardness is using a compound that is called using calgon. So you have to add calgon in water. So you have water, hard water, and where these either these four salts are present, that is basically permanent hardness. So this water is permanently hard water. So another one way you have seen to add Na2CO3. Second way, you will add calgon. What is calgon? The name of this calgon compound. Calgon is common name. Okay, but the chemical name is sodium hexametaphosphate. The name is sodium hexametaphosphate. Okay, many times this question come, what is calgon? So you have to write the chemical name. Now this sodium hexametaphosphate, I am writing its chemical formula, Na2 Na4. This is basically a complex compound, PO3 whole 6. That's why it is called sodium hexametaphosphate. This sodium hexametaphosphate, if you use it, then you can remove permanent hardness. But another question comes, okay, that is how you will prepare this calgon. Now, if you take one salt, if it is heated, many times in JE this question comes that there is one salt which is heated, then calgon is formed. Which was this salt and what is its formula? It is basically microcosmic salt. Microcosmic salt. When microcosmic salt is heated, then calgon is formed. Okay, so it is your homework to search in Google that what is the formula of microcosmic salt. Okay, so you will write the formula of microcosmic salt here. Okay, so when microcosmic salt is heated, then calgon will be formed. So up to this I hope it is very clear. The discussion is very clear, and this is the formula of Calgon. Don't it is not necessary to remember this formula, but I would emphasize that you just write at once this formula. Okay, watch this structure and just try at your own to draw this. Now, the last discussion, if you are in undergraduation or post graduation, then this discussion will help you. Okay, generally hardness of water, this we have already seen. Okay, hardness of water is due to this. Another one is iron is given Fe3 plus. Now the unit to measure hardness is ppm, parts per million. It is the unit of hardness, or gpg, gram per gallon. This is unit of hardness. Okay, now based on these units, there is one rating system. In this rating system, they say that which water is soft, which is slightly hard, which is moderately hard, which is hard, which is very hard. Just look at this data. Okay, don't you don't need to remember. Just look at the data, that what is the range, so that you can get a little idea about the hardness. Okay, now this is for your you have to read this. It is for your self study purpose. This is added, the difference between hard water and soft water. But for analytical chemistry, analytical perspective, analytical chemistry, how you will determine that, how extent of hardness, how you will determine that my water is very hard or something, how will you quantify it? For analytical chemistry purpose, this definition is given. Total hardness is a sum of calcium and magnesium concentration, both expressed as calcium carbonate in milligram per liter. So, in complexometric titration, using complexometric titration, hardness of water is determined. Okay. In complexometric titration, one indicator is used, that is EBT indicator. Full name is Eriochrome black tea indicator. And the titration is being done with EDTA, ethylene diamine tetraacetic acid. So with this, the titration is being done using EBT indicator. In this titration, you will get total Mg2 plus and Ca2 plus ion, amount of this ion, and you have to convert it to corresponding amount of calcium carbonate, and you have to express it in milligram per liter. Then only you will able to officially report the hardness of water analytically. Okay, in analytical chemistry, it is a volumetric method. Complexometric titration is a volumetric method. Another method is instrumental method. In any instrument, is it possible to determine the hardness of water or determine the concentration of calcium and magnesium? Yes, in instrument it is possible. One instrument is inductively coupled plasma mass spectrometry. Inductively coupled plasma mass spectrometry. Another one is ICP, optical emission spectroscopy, or ICP, atomic emission spectroscopy. In these two in these two techniques, you can instrumentally analyze the hardness of water, and you can report that how hard your water is. So the discussion is complete, and you have a holistic idea about hardness and softness of water. If you find this lecture helpful, let me know in the comment section. Till then, have a nice day. Jai Shri Krishna. Radhe Radhe.